So to start off today, we're continuing with section 2.1, analyzing loans, but we're going to start with two formulas that are new. So the formula that you already have is A equals P plus PRT. Now this is a simple interest investment perspective. So please write this down. Then we have A equals P times 1 plus R over N to the power of N times T. This is your compound interest investment. So you could use this formula. Oops, interest investment. You can use this formula, the compound interest investment one, if you're taking out a loan at compound interest, and you can do this from the bank's point of view, as long as you're paying it all back in one payment. Okay, but then we also have P equals A over 1 plus R over N to the power of N times T. So you'll notice that these two are the exact same, okay? But this one, we're actually just looking for the payment instead of the future, or sorry, the principal, the payment that you owe, instead of the future value. Okay, so they're basically the exact same. And then we do have a regular payment formula. So where R equals, this is the crazy one, R over N bracket 1 plus R over N to the power of N times T all over 1 plus R over N to the power of N times T minus 1. So let's start then with example 2. Jessie's employer loaned her $10,000 at a fixed interest rate of 6% compounded annually. So rate is 6%, it's compounded annually, and the loan is going to end in 5 years. How much will she need to pay her employer on the maturity date? So in this case, we're going to plug this into our compound interest investment formula where we're looking for A. So P is 10,000, your rate is 6%, number of compounding periods is annually, and it is 5 years. So we get 10,000 times 1.06 to the power of 5, which should give you $13,382.26. So how much of this is interest? Good, we're going to subtract our principal from this to figure out how much was interest. So we'll subtract 10,000, and the interest then is $3,382.26 that you're paying on this $10,000 loan. So in this case, your interest will come out to $3,488.50. Notice that monthly compounding periods means that you have to pay more interest than annual compounding periods. So it's better to take out a loan annual compounding periods than monthly. Next example, example 3. Annette wants a home improvement loan to renovate her kitchen. The bank will charge her 3.6% compounded quarterly. She already has a 10-year GIC that will mature in 5 years. When her GIC reaches maturity, Annette wants to use the money to repay the home improvement loan with one payment. She wants the amount of the payment to be no more than $20,000. How much can she borrow? So we'll use our second compound interest formula, which is P equals A over 1 plus R over N to the power of N times T. So in this case, we're looking for P. The future value that she needs can be no more than 20,000. So let's put down 20,000. The rate is 3.6%, and that is compounded quarterly, so 4 times a year. and she's taking this out in 5 years. Yeah, for 5 years. So then we're just going to solve. So 20,000 over. So when you go through all the steps, you should get $16,718.86, which is the maximum amount she could borrow. Now that makes sense because it's less than the future value. Thank you. So less than the future value because she has to owe some money to the bank also. So how much of this is interest? So your interest is always going to be your future value minus your present value, A minus P. So $16,718.86. So the interest that she's paying on this loan is actually $3,281.14. So example 4, Bob is negotiating with his bank for a mortgage on a house. He needs to make a 10% down payment, and the purchase price is $225,000. The bank offers a mortgage loan for the balance at 3.75% compounded semi-annually over a term of 20 years. So how much will each payment be? So let's write down everything we know. We need to figure out the principal, or how much he needs to borrow. So the principal is $225,000 minus the down payment. So the down payment is 10% of $225,000. So we're going to subtract $22,500 from this to get a principal of $202,500. We also know that T is 20, R is 0.0375, N is 2. I think that's all we need. So we're looking for R, the regular payments. So in that case, we're going to use our big formula right here. So we're going to use this formula. So R is what we're looking for. Let's just plug everything in. So what I forgot in the formula is we have to times this all by your principal. So we will figure out that it's 0.0394 over 1.1 times your principal, which gives us $7,253.18 semi-annually. Now semi-annually means every 6 months. So we have to divide by 6 to figure out that it's $1,208.86 per month. So then they ask, how much interest does he end up paying after he's done this for 20 years? So if he pays $1,208.86 per month, we have to times by 12, and he does this for 20 years. So how much money does he actually pay off in total? So it should be $290,127.27. So we subtract this from the amount that we owed, $202,500, to get the total interest equals $87,627.27. So that is how much interest he paid on this loan that he took out. So how much did he pay in total? We need to take the $290,127 that he paid to the bank and add that to the $22,500 that he put down to get a total of $312,627.27 is what he ended up paying for his $225,000 house over 25 years.